Very good morning to one and all. So, in the last session, we discussed about the uh, resistance spot welding. Now, we are going to discuss about the another type of resistance welding, which is called resistance seam welding or simply seam welding. Now, when I say seam welding, you can see a right top. I shown a picture. So we know that what is meant by seam, isn't it? What is a seam? It's a line where two pieces of fabric are sewn together or stitched together in a garment or in a other article. So that's called a seam. Okay, line where two pieces of fabric are sewn together. Likewise, and you may now wonder what does it has connection with seam welding. Yeah, the seam welding is also having an appearance like this. Now the seam welded joints, and if you look at the bottom picture, you can see that the welding is almost similar to the spot welding we discussed last time. The only difference is here you are using, can you identify? Yes, you are using a circular rolling electrode. That's the only difference I will say. The other remains the same. So the circular rolling electrons are used to produce continuous seam of overlapping welds. Okay, the circular rolling electrodes are used to produce continuous seam of overlapping welds. Now if you look at the schematic diagram, you can see the welding electrodes which is circular in shape, and you can also see just have a look at the overlapping welds, and also have a look at the cooling water which is provided. I will explain you why. Now what we can observe from this is the seam welding. The seam welding produces a continuous seam of overlapping welds, isn't it? Or the seam welding produces a number of weld nuggets on the weld material. And now what are the important parameters? If you look at the schematic diagram and on the left side the actual experimental setup, I mean the equipment, you can see by looking at this what would be the important parameters here in this welding. Of course, the application of electric current, whether it's a spot welding or it's a seam welding, we need to pass the current. That's important. So the magnitude of variation of current is important, and the motion of the electrode wheels. So these are the two important parameters here. Now you may please note that in a continuous motion seam welding, the electrodes rotate at a uniform velocity. The electrodes rotate at a uniform velocity, and along with this the current may flow continuously. Okay, the electrodes rotate at uniform velocity and the current may flow continuously, form the continuous weld seam. So these two things are important. So electric current and the motion of electrode wheels. Okay, as I mentioned, the seam welding produces number of weld nuggets on the weld material. Motion of electrode wheels and the application of electric current are the parameters. Please have a look at the right top, right bottom. You can see another picture where how the joint is made using a resistance spot welding. As I am repeating, the motion of electrode wheels and the application of electric current are the parameters. Okay. Now, when in this case, when the current is switched off and on quickly, when the current is switched on and switched off very quickly, and as a result a set of overlapping nuggets are formed. Yeah, that is what is shown in this picture. Three type of welds which is welding under the seam welding. So when the current is, so the first type is I was trying to discuss, when the current is switched off and on quickly, a set of overlapping nuggets are formed. Look at the B, picture B, and that process is called stitch welding, when the current is switched off and on quickly. Now when the duration of switching of current is increased, so you switch it off or you switch it on for a small period of time, and if you look at the picture number C, you can see that the space between the nuggets has increased. Okay, I mean the spacing between the individual nuggets increases, and you can see that it behaves like an independent nuggets. It's not overlapping like in stitch welding, and that's called a roll spot welding. The roll spot welding. So this is an example. And the first type is of course continuous welding, which means when the current is uniform, and also the current flow continuously without any break, and the electrodes also rotate at uniform velocity. So electrodes usually rotate at uniform velocity, and depending upon the flow of current, when the current is flow continuously, you will get a continuous motion seam welding, and when the current is switched on and switched off quickly, you will get a stitch welded joint, and when the period of switching on and switching off is increased, you will get a roll spot welding. And here the velocity remains the same. The electrodes rotate at a uniform velocity or at a uniform speed, and you can use this type of welding to weld. So the continuous motion welding is used for welding materials up to 4.5 mm thick, and for thicker materials, which means the materials which are more thicker than or above 4.5 mm, you will apply an intermittent motion welding is used. Intermittent motion welding is used. And what are the different materials you can weld using this technique? This plain carbon steels, alloy steels, stainless steels, aluminum, nickel, magnesium, and their alloys can be welded using this seam welding. And this welding produces very airtight joints, and the seam welding is used for fabrication of gas and liquid tanks. It's very interesting, and then widely used in oil and rig industries and also in space industries. The fabrication of gas and liquid tanks, transformers, refrigerators, evaporators and condensers, wherever the welding is required, first choice would be seam welding. The welding can be done only along straight line or uniformly curved lines only. This is another important information connected with seam welding. Now what is shown in this picture is a gas tank which is welded using a seam welding. You can see a nice seam welded joint here. And the main advantage of this, I already mentioned, you will get an airtight joint. That's the reason why the industries like gas and liquid tanks, for fabricating the gas and liquid tanks, the seam welding is used widely. So that's one of the gas tank which is welded using seam welding is shown in this picture. Thank you.